Hello everyone. Today we are going to see how to solve problems on differentiation involving trigonometric functions. There are some rules of differentiation of basic trigonometric functions, like ddx of sine x is cos x. Differential of cos x is minus sine of x. Differential of tan x is sec square x. Differential of cot x is equal to minus cosec square x. And differential of sec x is sec x tan x. Differential of cosec x is minus cosec x cot x. Okay. Differential of sine to the power nx will be n times sine to the power n minus 1 x and cosine of x. And differential of sine of a function of x will be cosine of the function of x into the differential of the function of x. Okay. So let's solve some problems. On trigonometric expressions. Let's say fx is equal to 1 plus x sine of x. So, differential of that function is equal to, differential of 1 is 0. Now we have a product of two functions. So, as we have done earlier, we take the first function x and take the differential of the second function. So, differential of sine x is cosine of x plus the second function, that means sine x, and the differential of x. Differential of x we know is 1. So the answer is x cosine of x plus sine of x. Okay. Let's take another function. Let's say fx is equal to cosine of x upon x. So the differential of that function is, now this is a fraction, so we have to apply the quotient rule. Okay. So the quotient rule says the denominator into the differential of the numerator. So differential of cosine of x is minus sine of x minus the numerator into the differential of the denominator. Okay. The differential of x is 1 upon the denominator squared. So this becomes minus x sine x minus cosine of x upon x squared. Okay. Here differential of tan x is sec square x. Let's prove this one. So if, let's say, if y is equal to tan x, let's say prove ddx of tan x is equal to sec square x. ddx of tan x is a y, okay, y slash. So let's see. So we know that y is equal to tan of x. Okay, let's split this into sine of x upon cosine of, because we know that tan x is sine x upon cosine of x. Now we will apply the basic rule of the quotient rule for differentiation of functions, that is a fraction. Okay, so y dash is equal to, we know that it is cos x into the differential of sine x, that is cosine of x again, minus sine of x into differential of cosine of x, because we know it is what? Cosine of x is minus sine of x. Okay, upon cosine of x whole square. Okay, that is cos square x. Okay, so this becomes cos square x, minus and minus becomes plus, sine square x upon cosine of square x. Okay, so we know the basic trigonometric identity, that is sine square x plus cosine of square x is equal to 1. So this becomes 1 upon cosine of square x, which is equal to, and we know that cosine of x is equal to 1 upon sec x, or sec x is equal to 1 upon cosine of x. So this is a reciprocal of cosine of x is sec x. So we can write here as sec square x. Okay, so we have proved basically that from these two basic relations, we have proved that differential of tan x is sec square x. In a similar way, we can also prove that the differential of cot x is minus cosec square x. Okay, so let's take some more examples. Let's say y is equal to sine of root of x. So y dash is equal to, we know that this is sine of, we'll apply this rule, sine of a function of x will be cosine of fx into the differential of that function. So here the function is root of x. So this will become cosine of root of x into the differential of root of x. The differential of root of x is, this is x to the power half. So differential of root of x is x to the power minus half, which is the same as writing cos of root of x upon 2 root of x. Okay, where x has to be greater than 0. Let's take another example. Y is equal to sine of 1 by x. So differential of y, differential of the function is, here we can say it is cosine of 1 by x, and differential of this x to the power minus 1. So x to the power minus 1 becomes minus x to the power minus 2. Oh, that means it is cos of 1 by x into or upon x to the power minus 2 goes down as x squared, and we add the minus sign. Okay, so let's see this one. Y is equal to 3 sine e to the power x. Now this is a exponential function, but the way we do it is the same. So here it will be differential of y will be 3 cosine of e to the power x, and then the differential of this function, which is again e to the power x. Okay, so let's see another one. Y is equal to cosine of 2x. So differential of y is, cosine is sine, so it will be minus sine of 2x, and then the differential of 2x is 2. So we can write this as minus 2 sine of 2x. Okay, so these are the some of the simple solutions to functions involving trigonometric expressions. Let's take a little bit more complex. Okay, so here y dash is equal to, we know that if you apply the basic trigonometric identity, that is 2 sine x cos x is sine of 2x. Okay, this is one way of solving it. So sorry, y is equal to sine of 2x. So y dash is equal to cosine of 2x, and differential of 2x is 2. So it is 2 cosine of 2x. Okay, let's solve it in the, this is one way of solving it. Let's solve it using just the basic rules of differentiation, where it is a product of sine x and a cos x. Okay, sorry, this is y, so this is y dash. Okay, let's see. Y is equal to 2 sine x cos x. So y dash will be equal to 2. This is the first function. Leave it as it is, sine x. Cosine of x is what? Minus sine x. Okay, plus. Second function, leave it as it is. Differential of sine x is what? Cosine of x. Okay, so we have here 2 minus sine square x plus cosine square x. Okay. Which is the same as 2. We know that cosine of square x minus sine square x is, again we apply the identity. So we get 2 cosine of 2x. Okay. Let's take another example. Y is equal to square root of 1 plus sine of x. So differential of this is, we apply this rule. So this is 1 plus sine x to the power half. So we'll say it is half of 1 plus sine x to the power half minus 1, that is minus of half. Then we will take the differentiation of this expression to give us 0 plus cosine of x. So we'll take out the 0. So we just have to multiply it by cosine of x. So this is equal to, answer is cosine of x upon 2 square root of 1 plus sine of x. Okay. So let's take another example. Y is equal to sine of to the power 5 of 3x. So now we will be applying this rule. So differential of that is 5 sine of 5 minus 1, that is 4 3x. Then the differential of sine 3x is what? Cosine of 3x. And then the differential of 3x is what? 3. So we are going to subsequently go on differentiating until we reach the innermost function. Okay. Bringing everything together, we get this expression cos of 3x, 15 cos of 3x, sine to the power 4 3x. Okay. Let's take still a little bit more complicated expression. Y is equal to cosine cubed ax plus b. So how do we do it? Y. This is first a power, so we'll do the power first. So this is 3 cosine of square ax plus b. 3 minus 1 is 2. Now we will take the cosine ax plus b and differentiate it. So we get minus sine of ax plus b. Okay. Minus sine of ax plus b. This is the second differentiation. And the third differentiation is that function itself, that is ax plus b. If you differentiate ax plus b, it will be a plus 0. So it is a. So finally we get minus 3a minus 3 and a. We gather the single terms, and then we can write sine of ax plus b multiplied by cosine square of ax plus b. Okay. So this is how you solve problems on trigonometric functions differentiation. Okay. That's all for today's lecture. Thank you for watching. Till we meet in the next lecture.